Hello and welcome, everyone, to the second session of the afternoon in the Lynn Conway Room. Just a reminder that if you're watching the live stream and you want to participate with questions, just let them in the chat room. We will now continue with the topic of real-time communications in Matrix, and I will hand it out to Timo and the ever-evolving changes in Matrix RTC. Big round of applause.
Yeah, thanks very much for the introduction. As already said, I'm Timo, working at Element, and one of the core people behind Element Call and Matrix RTC for a couple of years now. And yeah, I have the honor to talk about exactly that, Matrix RTC. And the talk is called Introducing a New Concept to the Matrix Specification. So why are we here? So we all want a good calling solution for Matrix, and we don't want it to be limited to one-on-one calls, and we even don't want it to be limited to just calls in general. We also want it to be more than VoIP, and that has historical reasons. There was this big project called thorugh, and also nowadays that is still a valid thing, because shared documents based on Matrix is super interesting, and there are even projects deploying this nowadays, and one really prominent one is NeoBoard. So in general, a flexible setup for real-time communication is super useful, and we really want to get this right. It is a quite complicated topic, though, because Matrix really gets put to the test if it provides all the required primitives to make Matrix RTC working. And one really good example to see why this is a little tricky to get right is that one of the amazing properties of Matrix is that you can have diverging networks and like network losses, and it will always converge at the end. But if you turn around the logic, this implies you can totally have time intervals where two home servers are in entirely different states for specific rooms. And if we're talking about real time, it's more in like 100 millisecond ranges. So we really don't want two home servers to be in different states, because then they of course have a different view on the current ongoing RTC session. So we are fighting a little bit some of the primitives, and to get the spec or to get the proposal through spec review, it just needs to be really good, because it really introduces something entirely new, and it shouldn't just be its own thing in a vacuum. It should be very well entangled with the rest of Matrix. Yeah, and we did a couple of iterations. As I said, it's a multi-year project now, and this talk will specifically focus on a couple of improvements that has been super recent. And yeah. So just to get everybody on board, we do a very quick summary of the main components of Matrix RTC. So it's not just one thing, it's a collection of things. And one is the RTC infrastructure. We also call this the transport nowadays, and also in the spec wording. And that is pluggable. So one of the most prominently implemented solution right now is LiveKit. But you could totally think of the transport also as a full mesh solution. So the one property the transport has to fulfill is getting media from one person to the other one, and everything else can be custom. And if there's like a new thing in the future, it's totally possible for Matrix RTC to then use this. I honestly really like LiveKit, and I know that they are also progressing and adopting future things, so maybe they will stay LiveKit forever, but the options are there. And I mean, there are also custom use cases in like a peer-to-peer world. We might want to have full mesh, so having this pluggable is useful anyways. And the other things, they are all covered by Matrix, basically. We have the signaling, we have the metadata and encryption. Encryption obviously is covered by Matrix. Signaling is everything that is happening inside a session, like who is participating, where do they publish the media. And the metadata is everything before and after. That is like almost not exactly connected to LiveKit anymore, but we really, connected to Matrix RTC anymore, but we really need to think to design Matrix RTC to be easily extendable, to have things like pre-calling communication where we want to exchange like ringing notifications and decline and those kind of pre-processing. And also after the call, we want to show a good history of which calls have happened. So what is great about the current proposal? It basically checks more boxes for VoIP than ever before. We have a very scalable solution, basically thanks to LiveKit. We have those interchangeable components. So it is a proposal that is flexible to emerging technologies. It is flexible in general, can be used for much more than VoIP. One example is the Neo board. There was a great talk, so if you have time after the conference, you can also check this out, or maybe you watched it already. And we get all the bells and whistles from Matrix. Secure, federated, it's even more federated now. We'll talk about this in a later slide. And verified identities, and yeah, all the things. And another new thing, that it's now also moderated by design. We'll talk about what this means. So to start this talk, we'll do a little journey where I have an example, and this example will be basically done twice. Once with the current solution before the new changes, to really get us all on board. And the analogy is basically chosen in a way so it's really obvious what problems it had, and then we'll solve those problems also with the help of this analogy. So we start here. That's a yard in a small neighborhood, and this yard has multiple houses. The houses represents home servers. And the yard itself is basically one room. So that's our encrypted room, and people from the home servers can participate in this yard. So if an RTC session is planned to happen, the inhabitants of the houses go out with an intent. They say, I want to participate in a real-time basketball match with the red group, and they all meet up and they find each other. So the participants are those 3 kittens, and now they know that they belong into one RTC session. And that is a very elegant and strong concept because it entirely resolves any negotiation. So instead of saying, how do we find each other and how do we do this, they can already at home decide, I will play with the red group and I'll play basketball, and there won't be a conflict where, let's say, another cat which brings the binoculars will end up in the same RTC session. So we don't have any negotiations, and a conflict-free solution for finding the RTC session. And then this is all Gen Z, so it would be super cute to have basketball playing cats, but sadly they just play PlayStation. So they all set up their stations, and now the big discussion comes, how do we connect our real-time media? And the way this works is they need some media server, like the LiveKit SFU, if we want to be more specific, and they need to negotiate. Everybody has its own home server, maybe with a different LiveKit SFU, but they want to be on one thing. And there's a rule to this. The oldest membership is the one that defines the server. So they have to discuss who was there first, which is the never-dying discussion. And they ended up with this server at the side of the street. They all connect to it, one red wire, one green wire for upload and download. And now they're all in one session, and they are playing happily. One thing is still missing, the encryption. And the simple solution is just put an encrypted password into the room. The room is still encrypted, so that's fine. So they send a room event with the password, everybody's using the same key, and we have a working solution. So how can we improve this? So what did the kittens not like? One thing was all others could see their passwords. That wasn't great. So even the green cat could see the password. Then the connection procedure, that was kind of tricky with all the discussion. And then when they connected their Ethernet to this server, they also put labels on their Ethernet wires to identify who they are, and they used their real Matrix usernames for this. So this slightly public on the street server did know their usernames, and that's one metadata that what they want to leak. And there's another party which we haven't yet talked about. That's the parents of the kittens, and they didn't like that they just played in the middle of the night on the PlayStation in the yard. So now the new thing, it's the same experiment, but we go through the different steps how we can improve it. I think I already made a couple of points which we will improve, quite obvious, but let's go through it slowly. So the first thing, the parents, they didn't like that they couldn't control it. So they removed the batteries, and instead they installed slots on the yard with charging ports, which they can turn on and off. And they also label the slot, so one slot is dedicated for playing basketball in red t-shirts. And that kind of changes the logic. So before we had this conflict-free system where the kittens were just meeting, and if they had the same intent, the same application and t-shirt, they just ended up in one call. And now it's basically that we have the slots as a first thing, and then the kittens can go into those slots to play. So it has like a dedicated room for those RTC applications. And the implementation, so for everybody who is using RTC already nowadays, it's not that dramatic of a shift. There it's more like a filter, so you just always have to download all the membership events, and then you just make sure that you only take the ones which are valid based on if their slot they want to participate in is also a slot that is open. So how does this look in the yard? So we have our slot moderation events, and they are just tables. They can be turned on and off, and they have a banner which dictates what t-shirt color and item is associated with the slot. So the kittens come, they go to the dedicated slot. That becomes a new meeting place for an RTC session, so the new centralized information. The other kitten is, of course, on the other table. And the next problem was the encrypted password, also simple solution. That's also something we basically presented last year already. They just exchange small paper notes instead of writing it all on the ground. And we call this two-device key sharing. So they use two-device messages, and nobody else in the room has access to the encryption keys except the actual participants in this one slot. So that's the little sticky notes they have where they exchange the passwords. Yeah. And then the last thing, that's basically the biggest topic, that was the whole negotiation they had to do, discussing where to connect and finding one consensus. And consensus is always not too great in Matrix. And the solution to this is you just publish where you want. So every kitten just decides where it wants to publish its media, and then it's on the receiving side, they have to figure out where the media is published and eventually also need to connect to multiple SFUs to download the media. And this might sound like a huge amount of overhead, but at the end, it's the same amount of upload connection. You just need to subscribe to each publication. And if you just look at the media data, even the media data consumption is unchanged. And if we look at one of the extreme examples, this in lots of scenarios doesn't even make a difference. If you have one group of people from one organization with one home server and one SFU, of course, everybody would publish to the same thing, and it would be exactly like it was before with the consensus algorithm. And we call this multi-SFU. So here's the concrete example. Two of the kittens connect to the house on the left, or to the media server on the house on the left. One of the kitten to the media server which we used before. It's still the same amount of upload connection. Everybody just uploads the video once. And from the amount of data, it's also the same. It's just that we use more wires now. So the kitten on the left just has one wire to download 2 media streams. The kitten in the center has 2 wires. One for downloading the media stream from the little kitten, and the other one to download the media stream from the kitten on the left. So there's no overhead in data consumption, it's just more signaling. And the last thing is the metadata thing. Also very simple solution. Instead of writing your actual Matrix username on the Ethernet wire, we just use a pseudonymous identity and do some UUID on it. And then the people in the room know which UUID they need to download from the SFU. But it's at least hidden for the media server. And in the example where the media server wasn't part of the home server, but external, that is super useful. So in some deployments, it might make sense to use a third-party third-party media server that just does media really good, and leaking as little metadata to this is really great, because there is a trusted relationship between users and home servers. But with an external media server, it would be amazing if we just don't leak any metadata whatsoever. So yeah, the solution is the pseudonymous member IDs. Here's an example. So we mimic this in our example with a little label. So each kitten has a label, and then it contains a UUID so the other kittens know where to get the media from. So those are the new changes, and we look into those into more detail. So basically the agenda is we first talk about the slot moderation event, then the member event and how we limit metadata, a little bit about key sharing, and then the big implementation change, and also like big big simplification of the multi-SFU. And for limiting the metadata, the pseudonymous member IDs is actually just a tiny bit. Really big change happens because we challenged if state is really the best solution. And there's a huge shout out to Keegan, who basically lead the whole project on finding the best solution for this. Lots of other element engineers were also involved, but there's this proposal of sticky events. Has come up in a couple of talks today already. But yeah, we'll also look into how this is used specifically for Matrix RTC. So we start with our slot moderation. Their main job is moderate RTC activities. And they are one central hub where we also can share store shared data for one RTC happening. The state key of this state event, so this really is a state event because it has to do with moderation and power levels, is a mixture of the t-shirt color and the application. So it's just the identity of this one session, and only the moderators can alter it. And it can also contain shared state. So in this basketball example, we have the application object, and there we have the type, and then we have the further field specific for the application. And an example for shared state could be the duration for this one match, because that's not something one person can decide. It's something where we need to find consensus for, and this is where we just use the state algorithm to find out which state event we use in the end. And then the state key is, again, as I said, the combination of play basketball and red. Or in our calling example, if we just have a room call, the color red is replaced by empty string, and play basketball is replaced by m.call. So m.call hashtag would be like the most default room call. There's still, like, if it's actually empty string, there's still discussions in the MSC, but the concept is the same thing. And yeah, this can have an open or closed state. Open means there's an application object in the state content. Closed means there's not. So it's like pretty easy to open and close the whole RTC slot event. Now we do look at the member event. So the member is the member event now needs to represent everything we had in our kitten. So I have those yellow comments, and they basically do our full analogy. So we first have our group identity, that's a slot ID. This is t-shirt plus item. Then we have the application, like if this person or this cat publishes media, how do we have to parse this media? Like basically the format of the real-time stream. In this case, it's play.basketball, and then the media will probably represent player position, ball position, whatever. And we can have application-specific user data. So things like its player role, that this is a center player. And then we have the ID in the member object, which we already talked about, to pseudonymously connect to the media server. And we have our transports object, and that can be basically or that is the Ethernet wire in our analogy, or can be described as where do I publish my data. And of course, every member can use a different transport, and that is how we get our multi-SFU solution. So if we look at this again, that is a connect event. It is a connect event because it has the application object in it, and it does not have a relation to a previous event. So if we look at an update event in contrast, it has the mRelates to field, which reference to the first connect event. So this way we can decide between a connect, an update, and a disconnect, and the disconnect is just, it doesn't have an application field and also no member field. So this allows us to basically have a full join period for one person. It starts with a connect event, multiple update events, and a disconnect event. And that is also something we already covered last year. We have a leave guarantee, and we do this by using delayed events. And the way this works, I'm trying to be short because there's like already resources out online, is that you can pre-send an event to a home server and then have a very generic API to control this pre-send event. So you say, send this event in 10 seconds. And then if you go offline, the home server will just send it in 10 seconds. But if you stay online, you can just refresh it every 5 seconds, and then it will never get sent. And this is a super elegant multi-purpose solution in Matrix to mimic such a behavior where you have somebody connected, and as soon as they use network connection, they send a new event to the DAG and that then represents their leave state. But it can be used for anything, like a timer, or you could even open and close a slot with a delayed event to do like timed operations. It's quite generic and useful in general. So now we go into this topic which I already teased. We try to even solve more metadata leakages. And at the top, like for the last slides, I always had this like general purpose description. Instead of going out into yard, we share our current state with the room. And I explicitly didn't choose we send a state event into the room, because we now want to think about what is the best thing this state could be represented at in a matrix world. We have a couple of requirements. The almost most important one is the delivery guarantee. So whenever I'm starting my client and I'm syncing, clients should be able to know which RTC sessions are currently ongoing. So without going through the full room list they have and pulling data for each room, they just want to know those are the ongoing sessions, to do things like show a big banner on the left-hand side, 3 ongoing calls, and provide user experience to join those. And then we want to leak minimal metadata. So best case, those state things would be encrypted. And it also should be compatible with the thing I just described with the delayed events, so that we can have this I lost connection and the leave will be sent semantic. And we used state events for this previously. It worked okay-ish, because you can share room state without backpagination. So you synced your client, all the state would be pulled down, and you would immediately know which session is in which room. You would use a different state key for each member, and it's totally compatible with those cancelable delayed events, which we just discussed. One issue is that you need to be able to have multiple devices joining the same session and also joining different application types with the same device. So at the end, to make a full state key, you can't just use a username, because then me joining in a different session would override my current session. So the full key would be user ID plus device ID plus application. And there's a concept in Matrix that if you use your username as a state key for state events, you're the only one being able to write to this. But as soon as my state key now needs to be this combination of 3 things, I'll end up in a world where this is not given anymore. So everybody could update their state, like they could update each other's state. And it would also bloat the state over time. And state has this full complexity of also doing state resolution and has a couple of specifics how it's syncing. And we don't need all of this. So it's just unnecessary overhead. And no encryption on top of this. So what if we would just use room events? And instead of having the state logic where the state key is basically presented to me as a map, we just fake this map by including information in the content. So then clients do know if this is a update or if this is a new participation in a different session. And that could totally work. So a keyed map, which is computed locally, is a very valid solution. But we don't have the delivery guarantee. So if I now start up my client and I want to know where are ongoing sessions, the thing I would need to do is go into each room and backpaginate to an unknown time to see if somebody started a call in the last couple of minutes, or maybe the call was really long. So I basically need to backpaginate a couple of hours. So that's a really big issue. And this is where Keegan's like multi-people effort, but Keegan driving it, solution came in with the sticky events. And one very simple pitch for sticky events is timeline events with a temporal delivery guarantee. So you can attach information to a timeline event, so it will be guaranteed to be sent for a limited amount of time. And we look into this more detail. So if that's and then we'll also discuss why this is so well suited for calls. So this diagram looks a little bit, it doesn't have lots of information to it, so I definitely need to give some additional ones. On the x-axis we have the time, and then whenever a bar is starting, that's basically the point in time an event was sent to the room, and then the length of the bar is the duration for which this event is marked as sticky. So I'm sending an event and I attach metadata in the query parameters and I say this is sticky for 10 seconds. So if we look at the purple one, it's sticky for, let's say, 30 seconds, and the red one is sticky for 10 seconds. And now whenever I do a sync, there is a new behavior. So we are only talking about initial syncs now. Whenever I'm continuously syncing, I'm only getting the new events anyways. And if we look at the beginning of the timeline, there the event was sent, and then maybe between the start of the purple bar and this dashed line, there has been, let's say, 200 new events. Then my client would be smart and not download all 200s, but just the last 10 or 20 ones to display me the most recent timeline. But with the sticky events, the server is now also checking, but wait, this purple event is still in sticky state for a couple of more seconds. So there's a new section in the sync, the sticky section, and there it will be included. So syncing at this time will guarantee me that I receive this purple event. And that goes for different points in this diagram. So here we have the blue event. It was sent so recently that it's still in the timeline section. But all the other events, they wouldn't be synced for just this initial sync. So they are in the sticky section. And then just one more example. Here we again have the yellow event in the timeline because it was just sent, and the blue event is in the sticky section. And just to make this double sure, this is not one client syncing, it's always new clients syncing for the first time in those different locations. Because of course otherwise there would be no need to resend the events. So how does this concept help us to have something like encrypted application state, which is basically a core thing we need for our Matrix RTC thing, where we have the kittens being in the yard, and that's our encrypted state, which we want to mimic. We need to build a local map for this. We use room ID, event type, user ID, and on top of this, sticky key. So I can have multiple parallel participations with one client and one user. We definitely need the delivery guarantee, like room state. That's basically what we just discussed. And the cool thing is, the bloating issue, that is entirely solved. Because now we have the sticky lifetimes, and eventually, like, all bars will be done. And there's no additional initial sync if I'm joining this room, if there's no recent ongoing Matrix RTC session. And by this Matrix RTC is basically the first adapter of a matrix-based solution for owned encrypted state. And the cool thing is it's also totally compatible with our cancelable delayed events. And now we have a quick look at the content. So we already talked about the slot ID, the application, the member, the transports, and the versions. The new thing is the sticky key. And this is a copy of the member ID field, and that just allows me that if I'm one client and I want to participate in a Neo board and at the same time in a element call, then I just send two participations with two different keys, and the clients in their local maps will not overwrite this, even though it's from the same sender. To understand this map concept a little better, there's one more diagram, and I basically model this map concept into two steps. The first thing is each client needs to have the same representation of just events, just a set of events that's happening on the left-hand side. And with sticky events, that's pretty easy to guarantee. So we have this point in time, and we have the blue event, the purple event, and the yellow event, and we'll definitely get those independent when we sync, because even if this is our initial sync, the sticky section will contain those events. If this wasn't our initial sync and we already synced for the whole time, we of course also would have the orange event. But there's an additional condition that clients do know the sticky duration, so they can locally compute when such an event is basically timed out. So if we look at this table on the bottom, we have the expiration. The blue event still lives for 60 seconds, the purple one just for 10 seconds, and the yellow one for another 30 seconds. But the red event basically lives for minus a couple of seconds. So the red event is just removed from the set of sticky events a client can compute. And now to morph the set into a map, we just look at the sticky key, and we see, oh, there are two sticky keys, A and B, so our map definitely has two keys. There's a conflict for two things that would like to be sticky, the data for key A. And there we have an easy algorithm, and that is just the older timestamp is the winner. So the purple event with timestamp 1 loses, and the one with timestamp 50 wins. And then we have our local sticky map, which is basically like state, super similar to state. And this is how we have encrypted application data, and this is how it's also done for Matrix RTC. Now we just do a very quick discussion about the call history, just to like round it all off. We have the connect and the disconnect events, so we know individual session, like participation intervals, and we also know the slot intervals, because a slot can be open and closed, and the overlap of those sessions and the open slot state that results in our collection of events which combined define the session. And then clients can just backpaginate, get all those sticky events, because they are still normal timeline events. They're just also sticky and have a delivery guarantee. And then the collection of events can be used to compute start time, end time, number of participants, who was there for how long, whatever clients decide is the best user experience to display a historic session. We do a very quick summary on the key sharing, because there will be a dedicated talk just about encryption and real-time things. So it's just the most basic concepts. We have our join and leave intervals. We have different sets of participations, and each colored section is a different set of participations. And whenever participants change, we rotate our keys, and that means we'll send a new to-device message to every other participant with a new key. And that guarantees forward secrecy and post-compromising secrecy, and it's what we are running for quite some time, and it works fairly well. And here's just a reference. So this is what we're currently talking about, the little notes they were exchanging. There's also like a more experimental idea, so it's basically hot from the press, similar to the password that was written on the floor. We can also have one shared encryption event, and that could be super helpful for very large calls. If we have like multiple hundreds of people, instead of sending multiple hundreds of to-device messages, we could just have one room event with one key and everybody use the same key. And the cool thing is, like, that was considered multiple times, but now with the slots, it's much more realistic, because of course we need to guarantee that everybody's using the same password, and it's very easy for me as a malicious client to just send a new password and then confuse the whole room. But with the introduction of slots, we have consensus, and the admin could just say, in the slot, I point to the encrypted room event with the key, and then everybody knows, okay, I will use the one which is basically promoted by the admin, and that would help us solve this race condition or consensus problem. Okay, now we go into basically the last topic. That's multi-SFU. I think we already gave like a little bit of an overview, but to be a little bit more technical. So before we had the focus active and foci preferred, which was kind of our concept where the data was stored for the consensus algorithms we've earlier proposed. And now it's just transport. So everybody just has a transport, and each member defines where and how they plan to transport their real-time media to other members. No election required. And here's just one example. So it's an array of objects, and each object represents one server or one method where I transport my media to, and one of those objects should contain all the data required to access the media from this one user. And as you can see, it's an array, so it's totally possible that I can say I publish over full mesh and over LiveKit at the same time. Not sure what this would be useful for, but maybe for like redundancy in places where you really don't want to miss any bit of the meeting. It's just a possibility. Not sure what it will be used for. And of course we can use different transport systems. And another interesting thing is now the application itself, like element call, for instance, needs to be possible to, or needs to be able to support all the transports. So basically the hierarchy here is that the application defines what transports it can support, because of course the element call app itself now needs to talk to LiveKit and also would need to talk to full mesh. And if an application doesn't support a specific transport, it can't be chosen. And for some applications, it also might make sense to only do full mesh, and then they can dictate that, yeah, you have to use full mesh. Implementation-wise, this was a quite radical and big change to the element call code base, because you can imagine, like, all the code was designed around LiveKit, so there was some connection function, and that connected to the LiveKit SFU, and then if we lost connection to the LiveKit SFU, it was a hard error. And if you hung up, you just disconnected from this one LiveKit SFU, and now you can have multiple ones. So it all needed to be refactored. So there's an array of connection objects, and each connection object manages its own state. And if there is a error in one of the connection, it's not a hard error, and you don't want to hang up the call. You want to try to reconnect for this one connection, and the others still work. So that was quite a bit of work, but we're basically there, getting this fully implemented. And yeah, at the end, the source of truth is always a membership event. That's just in this like mess which I just described, you can lose connection to your LiveKit server and then regain it. The source of truth is always a membership event. So whenever there's a membership event, I show a tile, and then I just have a state for this tile if it's currently connected or bad network connection, or yeah. Genau, and the tile is also the thing, or the membership event is also the thing where I decide on with whom I want to share my encryption keys. Okay, so basically those were like the really big changes for Matrix 2.0 calling. That's like the sticky events for our encrypted application state and our Multi-SFU, and now I'll give a demo where we have an element call version that supports all of this. So it's basically all already implemented. It's just not in a published version. And for this demo, we'll have multiple people joining. But of course, I'll also join from my side, give all the permissions. And then I join. We see there's already 4 participants. Now I'm waiting for media. I should mute myself just to be safe. And we have like a little debugging option enabled. It's not muted. There we go. And on the top corner of the tiles, we can see what SFU people are using. And they are indeed different. So Florian is on hes.earth, which is his private home server. Valea is on call.element.io. Robin is on call.element.dev. And I think I'm on matrix.org, which also has an SFU. Oh no, I'm also on call.element.dev. But in theory, probably Halfshot, who is still connecting. He's on... okay. Then I'm trying to connect to, so basically this is exactly the example I did. So currently the call is fully working, but probably my device currently just has a hard time to connect to the LiveKit home server from matrix.org for whatever reason. So I'm like still waiting for Halfshot. Should eventually converge, but the tile is still there since Halfshot has sent his sticky event. Yeah. That's it. So this is like fully Matrix 2.0 element call with all the nice bells and whistles, and how we also propose the MSC to the spec core team. So what's my time? I still have a little bit of time, right? Okay, because that is really good. There's another thing I planned. And that is actually demoing how we integrate element call in Cine. And there was a very short teaser demo in Florian's talk. But I wanted to take the time to give a little bit more background, because in general, like with this kind of, or basically the whole situation that there was like a spec change and then we improved element call and adapted it, that really makes clear how good the architecture is. That element call is a widget, and it can have all the complex new front-end changes in it. And on Element Web, we basically almost did nothing for this new change. So what I'm demoing here now is, if you're interested in your client to also support element call, you can do it by using, or support Matrix RTC for the m.call application, you can do it by using element call. You just need a client that has the Widget API, and the Widget API is currently implemented in both the JS-SDK and the Rust SDK. And with this little walkthrough of the code, we just go through, if you have a JS-SDK based client, how would you add calling? And yeah, I think we just directly dive into it. So the first thing is that you need two packages. One is the element call embedded version and the Matrix Widget API. And then you also need to add to your build system the embedded call object. And then lots of the steps is just copying over a whole bunch of code from element web. So this is just a lot of utils functions. So like get credentials, download from URL, like lots of tiny bits which are scattered all over the place. I now consolidated them into one thing which is actually needed. So they are in different utils folder of the element web repository. And then one of them is somewhat important. Oh no, this is not in here. So yeah, those are really just functions from element web which you need to copy over. And then another really big file is the call widget driver. So this is now all the widget driver code which you need for element call, which is a widget to talk to your own JS-SDK based client. To then, yeah, basically proxy through all the events. And this is also just a huge copy paste of element web. There are even like awkward comments like refactor widget kind into the widget class. And then the next big thing is the element call class. This is called stopgap widget in the JS-SDK. So that's also something we really try to refactor. But in this case, it's kind of nice that it's encapsulated in its own thing. So I could just copy it over. And here we'll have one look at the create call widget function, because that is almost the core of all this. The rest is just forwarding events to the widget. So we start with the base URL, and then we extend the element call thing. We give it a widget ID, and then we give it a couple of URL parameters. And the really important one is the intent, because that basically defines the configuration of element call. Because element call can be this SPA thing, where it's just in the browser as a single page application. But it also can be an embedded mobile UI, or it can be something that starts a call immediately. And all this is encoded into this intent. Yeah, and then you need to add things like widget ID and so on and so forth. So also not too interesting. And then we actually are already in front-end code. So this is a new class I created for Cine. It's called a call view. So this class should basically render the element call widget. We'll immediately scroll to the bottom. Oh, sorry, this is just boilerplate code for it. So basically, this is again just to make sure I show what code I bluntly copied over from element web. So it's like iframe features, sandbox flags, some styles, and this is the class I created, but it has no implementation yet. And the implementation happens in this change. So the most important bit is basically at the bottom here. We create an iframe with the correct embed URL. And for getting this embed URL, we just do a couple of things. So let's go through effect one by one. So the first effect takes this element call class I already created, and we just have a new element call object, and that is wrapping everything, like the widget communication and the object that has all the code to generate the correct URL. And then we store it into this React state. Then as soon as we do have this React state, we just call start messaging on it, and that is then actually doing the widget communication, and we have a cleanup effect for stopping the messaging. And then we have another state in this class, which is just the state of this widget call view, or like this call view in general. And we put this into the lobby state as soon as the widget is ready. And then we have a couple of more event listeners. So one is if the widget says I've got a hang up, we put the state into hang up. If I'm joining the call, we put the state into join. And if the widget says I want to get close now because I did the hang up and all the cleanup procedure, we put into the can close state. And that's basically it for the call view. And then the next thing is just adding this call view into Cine itself. So we just need a little bit of state if we show the call and if we are currently joined to the call. And then we just take this main room view. So we're currently in the room view. Okay. And instead of showing the timeline directly, we just add this call view in front of the timeline. And we make this conditional on show call. So whenever the call is shown, then yeah, we'll show it here. And then there's a little bit of changes to the header. I won't go into too much detail here, but that's just adding a button for pressing join. And then this sets this show call thing to true. And that's it. So if I now go into Cine, we have this button, which was the last thing I just showed. And if I press start call, I'm passing over an intent to this element call view. And that intent means we immediately join, and I should mute myself, and immediately go into a call. And also do send our ringing notification. So Florian's phone just rang. And we have a pretty feature-complete calling experience in Cine, even with a little chat on the right-hand side, where you can also write at the same time. Yeah, so that's my little demo. And since this is a thing Cine might actually want to have, we'll quickly go ahead and go here. Go to my repository and select the correct branch. I think I wanted to actually do the one in steps, so I squashed the thing for one, and create a pull request. We call this add element call to Cine, and then we do greetings from the Matrix Conference 2025. Cool. And now we can create a pull request and see what's happening in the next weeks. Don't check any of the boxes. I mean, this is what makes people really angry, but I think I don't have more time for this right now. I'll try to clean it up later. Cool.
All right, we have some minutes for Q&A. Do you have a question? Yes.
Great talk, by the way. It's interesting to see some of the challenges you had. With the new sticky event, so is the only change to support that is ultimately to the sync endpoint on the client-server API? Yeah. There's no like server-to-server stuff or...
I think there's also server-to-server stuff because you now also need to guarantee to deliver this thing. So basically, while an event is sticky, you need to make sure that the server actively pushes this event to other servers.
Right. Okay.
And otherwise, it often is that they just pull whenever somebody syncs.
Right. Okay,
and it might be so far behind the timeline that it's not getting pulled.
Okay, so it changes it from
yeah, and this is also the core thing about this. This is the property we need, that servers actually proactively federate this event, so everybody gets the same view of this local application state. Yeah, okay. Really good question.
Interesting. Thank you.
I have a question up in the back.
You mentioned pseudonymous IDs for the transport. Is this ID per application or per session or?
Actually, it's totally up to the user what they want to do, but it's best to change this as often as possible. So whenever I send a new connect event and a new disconnect event, for my next connect event, I totally should use a entirely new UUID just to make this as blurry as possible.
So is this used by element call that way?
currently it's not. So that is one of the pieces that it's almost Matrix 2.0. But yeah, it definitely will. Like no question about this. And it of course has less of an impact if your home server and the SFU is one thing. So for instance, if you use ESS, it's basically not really a security advantage. But as soon as you use something like matrix.org, where LiveKit provides their full cloud offering for matrix.org as a donation, then it might be very beneficial. So LiveKit doesn't know the usernames.
So also a question regarding the sticky events. If I understood correctly, the clients need to have the same time, right? Otherwise, durations could mismatch. Did you try breaking the system by changing time?
Yeah. So basically, that is also a thought we had, and we definitely use the origin server timestamp for doing the delta. But we noticed to really make this more resilient, the best thing we can do is that if a home server sends down the event, it actually includes a new field, and that is a unsigned server computer duration. And then all the local timestamp logic will use this unsigned field, exactly for this reason that it's less likely that home servers have a misconfigured clock than the clients. It's of course still up to the client what they'll then use in the end. If they have like some API to online sync, they might trust this even more, but the implementation is really recommended to use this server computed duration timestamp. Yeah, good question.
Cool, thanks.
From the audience? Oh, there's a question here.
Hi, thanks, great talk. On the fear of being annoying, you mentioned the widget, like you used a widget, right? So I assume the widget is fully spec'd by now? It's like, can we use this? Is there...
So basically the way I would treat widgets nowadays is mostly an implementation detail for element call and the neoboard. So it's more thought of as clients who want to have more features. They can use the widget API to add those features. But yeah, I mean, it is a dream of multiple people to really have a specification for this. And by Matrix being a monolithic specification, it would be possible to have widget support on all clients. It's just not there yet. And there are also there are definitely new things because the widget API now will be able to talk through the sticky event stuff. So there are definitely additions, and everything we do in element call is well documented in the widget. And we even do write or go the extra route and write MSCs for it. It's just that there's no hard push to really get those MSC to the spec core team and merge them. But there's like plenty of progress on the MSCs themselves, which doesn't make them merged, sadly. Yeah.
Okay, we have a question in the chat room. So most platforms rely on Apple and push and Google for push notifications, in this case call notifications. Are you exploring decentralized or self-hosted notification systems to reduce this dependency?
I'm actually not entirely sure. So we as a team, we don't specifically explore this. We do explore a bunch of things to make it more reliable. There's actually also an idea for the notification event to also be sticky, because it even can be that like your home server sends you the notification, but then your client syncs and it doesn't get the event anymore, and then yeah, it's kind of a lost string. But there's no active effort in exploring other solutions than like the default ones. But that is, of course, something that would be super great. I would be super happy if we have resources for this. So if that's something somebody's interested in and wants to work on, it also feels like something, if that is solved, it would be solved for, yeah, lots of use cases, not just element call ringings.
Okay. Any further questions from the audience? If no, let's wrap up with a big applause for Timo.